This question is one that I've seen in many, many places, and it's something that really troubles a lot of Python developers who don't quite understand the intricacies of how functions work. So here's my function, def add1 with a default of x equals empty list. And I say x append of 1, return x. And then I run this function 3 times. What will the response be? What will the return value be from that final time? And the answer is, of course, 1, 1, 1. To which you might say, of course, what are you talking about? What happened here? So let's take this little by little. First of all, I've defined my function here, add1, and it has a default value, meaning if I call it with an argument, if I say my list equals 10, 20, 30, and then I say add1 of my list, then we'll get back 10, 20, 31, and indeed my list has actually changed. That's normal, that's reasonable, that's what we would expect, because I call the function. The function knows that it needs to get an argument there. It knows that it requires one positional argument. We provide that positional argument, my list. It then says, okay, x, the local variable, and my list, the global variable, then point to the same object. We then say x dot append. That's going to append to the object. Whether you call it x, whether you call it my list, doesn't really matter. We add 1 to it, and then we return it. So the return value is displayed here. So far, so good. And my list has also changed. Nothing exciting there. What happens when I call it without any value, add 1? Well, if I do that, add 1 has to check how many arguments is it supposed to get. How does it know that? Well, it actually goes into its code object and says, hey, what's my COArg count? How many positional arguments am I supposed to get? And the answer is 1. So if I call add1 and I don't provide a positional argument, it's in trouble. So it says, wait a second, before I raise an error saying you didn't provide enough arguments, maybe, just maybe, I have a default value somewhere. So let me define this function once again, just so we're not going to mess things up. And so if I do this, I now say add1 under defaults. What do we have there? We have a tuple. Oops, sorry, defaults, plural. We have a tuple, and that tuple contains an empty list. Where does that empty list come from? Well, when we define the function, we told it that the default will be an empty list. And this is where the conceptual problem comes in. Many, many, many people think that what this default means is if someone does not pass an argument, then we should use an empty list. Not so. When we call this function without an argument, we are going to use this empty list. Because what's going to happen? Python's going to check what's the arg count. The arg count is 1. But we called it without any argument. So it says before I throw an error, I'm going to check to see if I have something in defaults. It pulls this value out of defaults and then basically says x equals, add 1 defaults 0. That's what it's doing. Now, obviously, it's doing it locally. It's doing it behind the scenes, but that's what it's doing. Meaning we're grabbing that list. Now, here we have a tuple with a list inside of it. Lists are mutable. Lists can be changed. And indeed, when we call add1, now it's going to say x.append of 1. What's that going to do? It's going to change our list from being empty. It's going to now contain 1. Have we only changed it where x refers to it? Not at all. X, the local variable, and add1 under defaults, the attribute that sits on add1, are both references to the same list. So if we do an append to that, it gets appended to. And indeed, I'm going to call it here. We're going to get back list with 1 in it. And now if I say add1 dot under defaults, what are we going to see? Our tuple of defaults with a list. And in that list, we have the number 1. And each time we call the function without an argument, it's going to go back into defaults, pull out the reference to that list, and then append to it. This is sort of a dark corner, or the combination of seemingly reasonable ideas in Python that combines to really make a lot of havoc for people. And by the way, I've seen sometimes people say, oh, that's great. What a fantastic piece of functionality. I should use this in my program, sort of like a static variable in other languages. No. Don't do that. The defaults are not the place where you want to be storing information that's going to be kept from invocation to invocation. You really don't want to do that. So how are we supposed to write such a program? What we want to do here is say, if the user calls our function with a list, great, we're going to append to it. And if not, then we want to create a new list. If you want to create a new list with every invocation, you don't want to put that list here in the arguments, in the defaults. Instead, I'm going to say here none. And then I can say if x is none, then x equals an empty list. Now, because this assignment is happening at runtime, and not a compile time, there's no trouble at all. I'm creating a new list each time, and sure enough, now I can say, add 1, and I'll get back empty list with 1. Add 1, I'll get back empty list with 1, and each time it's going to create a new list. Now, this is the sort of thing that you should be worried about a little bit, even a lot, and this is known as the problem of having mutable defaults. And the bottom line is never use mutable defaults. If the defaults to your function are mutable, lists, dictionaries, sets, bad news, don't do it. Step away, because you will at some point encounter this sort of weirdness. Good code checkers, like the ones that are built into PyCharm and VS Code, things like Pylint, will notice this and warn you about it. They'll say this is a dangerous thing to do and you should really avoid it. And now you know why.